This university has a degree program in the undergraduate called BSc in Applied Optics and Lasers. This is the only program of its kind in this country and in the region. We are training in the area of optics and lasers. We got a funding of about 66 million from National Research Fund, and the purpose of that was to buy research infrastructure for a center to train in optics and lasers.
I would like to sincerely thank the CEO of the National Research Fund and her team for considering the Multimedia University proposal and funding these labs.
As a result of that, we have been able to buy a whole range of equipment ranging from the optical tables, which are surfaces on which we mount the optical setups. And these surfaces, they are very key because you cannot set an optical experiment without an optical table, because other surfaces are highly unstable. And these surfaces, by virtue of the way they are made, they are actually stable and they cannot bend. The surface will remain straight, and that is very important in an optical setup. On top of that, we also have what we call Fabry-Pelot interferometers. These are equipment that are used to analyze the properties of light, especially when it is coming from a laser.
Lasers is a light amplification of radiation and stimulated emission, and for this we have an experiment called Michelson interferometer. I can just name the components. We have a laser source here, and then we have a mirror here, which will be fixed mirror, and then we have a movable mirror. We also have a beam splitter, and we have a lens.
With the Fabry-Pelot interferometer, we can be able to analyze any laser in the market. What we have to note is just the wavelength. What is the wavelength of the laser? We have 3 Fabry-Pelot interferometers for different wavelength ranges. So depending on the wavelength range of the laser that we want to analyze, we are going to choose the appropriate Fabry-Pelot interferometer. And this equipment we can use even to diagnose a laser. For example, a laser which is not functioning as required. And this could be even medical lasers, lasers in the industry, lasers in research institutions. And once we note that this laser is not operating optimally, we have the expertise of actually seeing or diagnosing what could be the cause of the dismal performance of the laser.
We have a recording here from a camera to the laptop, so that now we can be able to analyze. So we analyze from the movements of the interference fringes, the ones that we had noted, we can now be able to see, and by these interference patterns, we can be able to see how much the mass has changed of the particular component that you are using. So this is a part of the application of Michelson interferometer.
We also have highly sensitive, efficient, powerful cameras. We call them the CCD cameras. We have colored CCD cameras. We also have black and white CCD cameras. And these are important, for example, in capturing information in any optical experiment. We also have optical spectrum analyzer. This helps us to determine the wavelength of the source of light that we are using. We have microscope objectives with various variants of numerical apertures.
We are making use of this setup of 3 elements to generate a three-dimensional image, like an image with depth. We're trying to generate that from an image printed on a flat piece of paper, just a regular transparent sheet. It's just like the negative for photograph, making use of a halogen lamp which gives us white light, which has all the colors of the rainbow. Then we make use of the object which has the photograph, then polarizing sheets so that they can, which are of the colors red and blue, because red and blue are primary colors. Once we make use of the red and blue polarizers, we can generate almost any color. Finally, we have the objective lenses which magnify the image so that we can be able to see something slightly bigger than what is displayed on the film.
We are also using these facilities for demonstration purposes. For example, students, when they come to visit our university, we demonstrate, we use setups to show the properties of light to the students, that light is wave, but light is also a particle. You know, some of these concepts, students just learn them in school, but there is no way to actually demonstrate to them. So we are able to demonstrate to the students quite a lot of experiments they even encounter in school, or phenomenon that are encountered in nature. And sometimes people think this is just a miracle that is happening. But it's something that can be explained by science. It's an optical phenomenon. So we have that opportunity here to expose our runners, even at lower levels. May the government continue to fund NRF so that this institution can be able to fund Kenyans, and also to fund institutions to be able to train and to support research in the country. I've had the honor of traveling to a few institutions across this country, and I can tell you, every institution that have been able to have an opportunity, there is a mark of NRF.
Thank you very much.
Assistance.